In this lesson, we will learn how to calculate weighted averages, and we will learn some general properties of weighted averages. To set this up, consider the following. Let's say we have 6 men and their average age is 20, and we have 6 women and their average age is 40. Now what happens if we combine these two groups? What will be the average age of the combined population? Well, if you said 30, you're right. To see why, let's find the sum of the ages of the men and the sum of the ages of the women. To do this, we will use the following formula. So since the average age of the men is 20, and there are 6 men altogether, the sum of their ages will be 20 times 6, which is 120. When we apply the same formula to the population of women, we see that the sum of their ages is 240. Now let's see what happens when we combine both populations. The average age of these 12 people will be the sum of all 12 ages divided by 12. So the sum of the men's ages is 120, and the sum of the women's ages is 240. We will now divide this by 12. When we simplify this, we get an average of 30. Notice that the average age of the combined population is equal to the average of the average ages of the two original groups. Okay, now let's take the original question and change it slightly. Let's keep the average ages of the men and women at 20 and 40 respectively, but let's remove 4 of the men. Now, if we combine the two groups, what will be the average age of the combined population? To determine this, let's take the two original groups and find the sum of their ages. Once again, we will apply this formula. For the men, the average age is 20, and there are now 2 men, so the sum of their ages will be 20 times 2, which is 40. When we apply the same formula to the women, we see that the sum of their ages is 240. Now, when we combine the two groups, the average age of the 8 people will be the sum of all 8 ages divided by 8. The men's ages add to 40, and the women's ages add to 240, so the average age of the combined population is 35. Notice that this time, the average age of the combined population is not the same as the average of the average ages of the two original groups. Okay, now let's look at a different way to find the average age of the combined population. To do this, we need to recognize that the average age of the entire population depends on the proportion of men in the group and the proportion of women in the group. Now, in this population of 8 people, we have 2 men. So the men comprise 2/8 of the combined population. At this point, we'll take this fraction and multiply it by the average age of the male population, which is 20. Now, to this calculation, we will add the contribution of the female population. So in the combined group of 8 people, we have 6 women. So the women comprise 6/8 of the combined population. We will now multiply this by the average age of the female population, which is 40. Now, when we simplify this, we see that the average age of the combined population is still 35. We can now take these results and generalize them as follows. If we are combining 2 or more groups where we know the average of each individual group, then to find the weighted average of the combined population, we will take the proportional representation of one group, say group A, and multiply it by the average of that group. Then we will do the same for another group, and so on. Okay, now let's apply this formula to the following question. Here we have 3 classes of Calculus 101. Class A has 20 students, Class B has 30 students, and Class C has 50 students. We are given the average test scores for each class, and we want to determine the average score for all 3 classes combined. Since there is a different number of students in each class, we can use the weighted average formula. So first, let's determine the total number of students in the combined population. When we add the populations of each class, we get a total population of 100. So to find the average score for all 3 classes combined, we will begin with Class A. Class A has 20 students, and there are 100 students in the entire population, so Class A represents 20 100ths of the population. We will multiply this by the average score in Class A, which is 90. Now on to Class B. Of the 100 students in the combined population, 30 of them are in Class B. So Class B represents 30/100ths of the population, which we will multiply by 82, the average score in Class B. Finally, Class C represents 50/100ths of the population, and the average score in that class is 66. When we simplify all of this, we see that the average score for all three classes combined is 75.6. Okay, that's how we calculate weighted averages. Now let's look at some properties of weighted averages. To set this up, let's go back to the results of some earlier examples. In the first example, we began with 6 men and 6 women. The average ages of each group are 20 and 40. When we combine these two groups, the average age of the combined population is 30, which happens to be the average of 20 and 40. In the next example, we removed 4 men from this group and then combined the two groups. At this point, the population of women is greater than the population of men. As such, the average age of the women carries more weight, which means the average age of the combined population changes when it slides over to the heavier population and becomes 35. Similarly, notice what happens when we remove 2 women from this population. In this scenario, the population of men now outweighs the population of women. So as a result, the average age of the combined population slides over to the heavier population and changes to 28. We can summarize these results as follows. To set this up, let's say that Group A has some average measurement A and Group B has some average measurement B. Now, when we combine these two groups, the average of the combined group will depend on which group has the greatest population. This gives us 3 cases to consider. Case 1 is that the population of Group A equals the population of Group B. If this is the case, then the average of the combined group will be equal to the average of the averages of the 2 individual groups. Case 2 is that the population of Group A is greater than the population of Group B. If this is the case, then the average of the combined group will be closer to average A than it is to average B. Finally, case 3 is that the population of Group B is greater than the population of Group A. If this is the case, then the average of the combined group will be closer to average B than it is to average A. Okay, let's summarize. In this lesson, we learned how to calculate weighted averages, and we learned 3 properties of weighted averages. In this lesson, we will examine 2 ways to measure dispersion. In other words, we will examine ways to measure the degree to which a set of numbers are spread out. The first measurement we will look at is range, and the second is standard deviation. Now, to set the stage here, please consider the following scenario. Let's pretend that you are in your early 20s and you want to take a bus tour somewhere interesting. A travel agent has found a tour that leaves tomorrow and the price has been drastically reduced. However, before you say yes to the tour, you want to learn a little bit more about the other passengers on the tour. So first you ask the agent how many other people are signed up for the tour, and she tells you that 10 people are signed up. Next, since you want to travel with people your own age, you ask for the average age of the other travelers, and the agent tells you that the average age is 22. Now, since you happen to be 22 years old, this sounds like a great trip. The only problem is that there are many possible ways in which 10 people can have an average age of 22 years. For example, all 10 people could be 22 years old, in which case the average age is definitely 22. Or these could be the ages of the 10 people, in which case the average is also 22. We should also recognize that the ages could look something like this, and still have an average of 22. So as you can see, although the average is 22 for all 3 sets of numbers, the numbers themselves are quite different. So knowing only the average age does not necessarily give us a clear picture of the population. Now, another useful piece of information here would be to know how dispersed the numbers are. One way to measure this is to use the range, which is equal to the largest number in the set minus the smallest number. So for the first set here, the range equals 22 minus 22, which is 0. For the second set, the range equals 26 minus 18, which is 8. And for the last set, the range equals 80 minus 1, which is 79. So as you can see, knowing the average value and the range gives us a better idea of how a certain population looks. Now it should be noted that the range has certain limitations when it comes to accurately describing a population. To show these limitations, let's continue with our example here. Let's say that the travel agent tells you that in addition to the 10 travelers having an average age of 22 years, the range of ages is 79. Given this information, the ages could look like this, or possibly like this. Both sets of numbers here have an average of 22 and a range of 79, but as you can see, the sets are quite different. So the problem with range is that it only tells us about the extreme values in the set. It doesn't tell us anything about the numbers in the middle. For example, in the first set, the traveler whose age is closest to yours is still 8 years older than you. Conversely, in the second set, there are 6 travelers who are between the ages of 21 and 24. So although range does provide some information about how dispersed the numbers are, we need a measurement that goes beyond telling us the difference between the two extreme values in a set. That's where standard deviation comes in. The standard deviation measures the extent to which each and every number in a set deviates from the mean. Here's how standard deviation is calculated. To find the standard deviation of values from x1 all the way to xm, we will need to know the mean of the values and the total number of values. Once we have this information, the standard deviation, SD, is calculated as follows, where x1, x2, x3, and so on are the individual numbers in the set. So let's use this formula to find the standard deviation of this set of numbers. To do this, we will first calculate the mean, which is 4, and we can see that n, the number of values in the set, is equal to 5. When we plug these values into the formula, we get the following. From here we can simplify the information in the brackets, and then we'll square each of these values. This simplifies to be the square root of 3.6, which equals approximately 1.9. So the standard deviation of this set of numbers is 1.9. Now it's very important to know that on the GRE you will never be required to use this formula to calculate the standard deviation of a set of numbers. In fact, questions involving standard deviation will typically test your knowledge of what standard deviation measures. Since this is related to the way standard deviation is calculated, let's see if we can get a better idea of how this formula works. To begin, notice that the information inside each bracket here is telling us how far each number in the set is away from the mean. For example, here we are finding the difference between 1, the first number in the set, and the mean, which is 4. When we subtract these values, we get -3. So essentially, the first number, 1, is 3 units away from the mean of 4. Similarly, this -1 here is telling us that the second number in the set, 3, is 1 unit away from the mean of 4. Now, in an effort to handle the various negative numbers that can arise in this formula, we square each difference, which turns them into positive numbers. Once we add these numbers together, we divide this sum by 5. So in essence, we are finding the difference between the mean and each number in the set. Then we square those numbers, and then we find the average of those squares by dividing by 5. Finally, to undo the squaring that we did earlier, we take the square root of everything. From all of this, we can develop an informal definition of standard deviation, which will allow us to forget everything we know about the formal definition. The informal definition says that the standard deviation is the average distance the data values are away from the mean. This definition will be all you need to know to tackle all standard deviation questions on the GRE. So let's use this definition to find the approximate standard deviation of the numbers we just used in the last example. So first, we will calculate the mean of the numbers, which is 4. Now that we know the mean, we can determine the distance that each number is away from the mean. The first number is 1, and it is 3 units away from the mean of 4. The second number is 3, and it is 1 unit away from the mean of 4. The third number is 4, and it is 0 units away from the mean. Next we have 6, which is 2 units away from the mean. And finally we have another 6, which is 2 units away from the mean. Our informal definition says that the standard deviation is the average distance the values are away from the mean. To calculate this average, we will add up the 5 distances and then divide by 5. When we do this, we get a standard deviation of 1.6, which is close to the standard deviation we calculated using the formal definition. However, as I said earlier, you will never be required to calculate the standard deviation of a set of numbers on the GRE. Alright, now let's examine a few properties of standard deviation. First, the standard deviation of a set of numbers is always greater than or equal to 0. Second, whenever a set contains identical numbers, the standard deviation of that set is always equal to 0. Now, a popular question type related to standard deviation asks us to examine various sets of numbers and determine which one has the greatest standard deviation and which one has the least. Please note that we don't need to actually perform any calculations here, since we should be able to deduce upon inspection that set C must have the greatest standard deviation. What about the least standard deviation? Well, the numbers in set B appear to deviate the least from the mean, so it must have the least standard deviation. Okay, now let's return to the sets of ages we examined earlier. Both have an average age of 22 years, and both have a range of 79. Which of these two sets has the greatest standard deviation? Well, let's use the informal definition of standard deviation here to help us. Since both sets have a mean of 22, it should be easy to compare these numbers. Now, the first number in each set is 1, so each number is 21 units away from the mean of 22. The second number in the top set is also 21 units away from the mean of 22, and the second number in the bottom set is 20 units away. Now, things get interesting when we get to the middle numbers in each set. This number is 18 away from the mean of 22, and this number is only 1 away. This number is 15 units away from the mean, and this number is 0 units away. This number is 9 units away, and this number is 0 units away. This number is 8 units away, and this number is 1 unit away, and so on. As you can see, the numbers in the bottom set are closer to the mean than the numbers in the top set. As such, the standard deviation of the bottom set will be less than the standard deviation of the top set. In fact, if we apply the formal definition of standard deviation to both sets, we find that the standard deviation of the top set is about 24.6, and the standard deviation of the bottom set is about 21.5. Okay, let's summarize. In this lesson, we learned how to measure dispersion using the range and using both the formal and informal definitions of standard deviation.